Hey guys, in this next video I want to continue learning how to graph functions using a table of values. We're also going to talk about briefly this phrase right here called a function family. And we're going to talk about this a lot more actually in 4.4 day 2, but just to introduce you to this concept, a function family is actually a group of functions that share certain characteristics. Okay, so we're going to see some different types of graphs in this video right here, some different shapes, not all of which are lines like we had in the last video. And in the next video, 4.4 day 2, we're going to learn what the different names of those different graphs are that all have similar shapes but maybe different sizes of those shapes. Okay, so for now we're just going to get an introduction and talk about how to graph them using a table of values, and then the next video we're actually going to do a little bit more in-depth exploration of those. What I do want you to have ready though is your graphing calculator, because I want you to actually be able to see the shape of each of these graphs before we actually use our table of values, just so you know kind of what shape to expect here. Again, for the actual test, you're not going to be allowed to have a graphing calculator, but I do want you for the notes just to use it just to get an idea of what kind of shape to expect. And then as we practice this a little bit more and look at the next video, we'll learn we'll learn what shapes we can expect to see based on the equation. But since this is brand new, it's going to be easiest for you just to have your calculator and use that to start with. Okay, so for number 1, we have the function f of x equals 2x minus 3. So I'm going to set up my table of values here. And again, I'm going to use the standard -2, -1, 0, 1, and 2 for my x values. Okay, unless I have a fraction for each of these, that's what I'm going to go off of. And then I'm going to pull out my graphing calculator, and I am going to type in that function in my graph screen, and I'm going to show you how you can graph on your calculator. This will be the first time we've actually done this on our calculator. Okay, so actually let me go back to my home screen here. If you're on your home screen, you're going to go to either B, the graphing mode, or you can click your scratch pad here. Okay, and if you get this screen right here, then you can just click your scratch pad again. That will take you to your graph screen. Okay, and then if you hit tab, that's going to bring up this little bar down here. Okay, and it's going to say f1 of x equals, and so that's going to allow you to type in whatever comes after the equal sign for each of these functions. Okay, so we're going to type in for our function right here, we have f of x equals 2x minus 3, so we're going to type in the right side of that equation, 2x minus 3, just to get an idea of what the line looks like. Okay, so 2x minus 3, and if I hit enter, I should get a line. Okay, just like in the last video, we got several lines. Okay, now you'll notice your graphing calculator doesn't put arrowheads on the end, but whenever you're graphing something on a calculator, it's assumed that this keeps going forever and ever. Okay, later on I'll teach you how to zoom out for this. So this, if we were graphing this by hand, this should have arrowheads on the end. So now what we're going to do is we're going to actually plug our x values into our function rule and just see if we get the same shape. So this is going to look similar to what we did in the last video. I'm going to take 2 times my x value every single time and then subtract 3. What I'd like you to do is I'd like you to pause the video and then just practice this again. So plug each of these values in to get the y coordinates. Graph each of those y coordinates and see if you get a graph similar to what's on your graphing calculator. And once you've done that, go ahead and click play for me. Okay, for this one right here, you should have gotten these different y values here, -7, -5, -3, -1, and +1. And so when you plot each of these coordinates on your coordinate plane, you should get these 5 points, connect the dots, and you should get a straight line. And I kind of cheated. I used my straight line tool for this because it gets pretty squiggly when I try to freehand it on my computer. But again, you're using a straight edge, a ruler, when you're connecting your points here. And so now what we're going to do for each of these is we're going to answer just a few questions about the graph. The first question is asking, is the graph increasing or decreasing? And all that means is what's happening to the y values as you move left to right? Okay, so are the y values getting larger or smaller as I move left to right? Well, for this graph here, if we read it from left to right, it's sort of like we're going uphill. Okay, if I go from left to right, my y values are getting larger. Okay, I start out at -7, then -5, then -3, then -1, then 1. So we could say that the entire graph is increasing based on that. Okay, reading it from left to right, we're going uphill, so we are increasing. A decreasing graph would look something like this. Okay, that would be an example of a decreasing graph. Does the graph have a maximum or minimum? We're going to say no for this one because there is no highest or lowest point on this graph. It keeps going forever and ever this way and forever and ever this way. And so there is no maximum or minimum point on this graph. Okay, and then the final question, is the graph a curve or a line? Well, obviously this one is a line, so that's an easy question to answer. Okay, moving on to number 2 now. We have f of x equals x squared plus 3. I'm going to do the same thing that we did in the last problem. Plug in my standard x values of -2, -1, 0, 1, and 2. I'm going to set up my table like this, so we know we're going to take our x value, we're going to square it, and then after that we're going to add 3 every time. So I'll go ahead and set that part up. But now before I go ahead and I set up my table, I do want to plug this graph into my graphing calculator just to get an idea of the shape. So if you go back to your graphing calculator, what you can do for this is to get rid of this graph right here, you can actually hit your delete button 3 separate times. So if you hit delete, 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 you should get this screen pop up that says, are you sure you want to delete everything? You can click yes, and that'll make your graph disappear and allow you to put a new graph on there. So we're going to hit tab again to bring up this bar at the bottom. This time we're going to type in x squared plus 3. So I'm going to hit my x, and then I'm going to hit my squared button, which is right here next to my 4. Okay, you see an x squared. If you just type that button, that's going to put in your exponent of 2, and then we'll type in plus 3. We hit enter, and you see we get this sort of a U shape. Okay, we're going to talk more about what this shape means again in the next video, but this is the shape we should expect to see on our coordinate plane when we graph this. So now let's go back to our notes. Let's plug in each of those x values, starting with -2. So when you square -2, you get a positive 4. 4 plus 3 is 7, so we get the point -2, 7. So I'll go ahead and I'll graph that right now. Okay, there's -2, 7. Then we plug in -1. -1 squared is 1. Plus 3, you get positive 4. So we have the point -1, positive 4. Then we plug in a 0. 0 squared is 0. Add 3, we get 3. So now we have the point 0, 3. Plug in 1. 1 squared is 1. Plus 3, you get 4. So again, the point 1 back up to 4. And finally, we have the 2 to plug in, so we'll plug in a 2. 2 squared is 4, so 4 plus 3 is 7. You get the point 2, 7. And so this graph does look similar to the shape we had in our graphing calculator. This does sort of have that U shape. So now we're just going to connect those dots in a curve manner, since a U would be more of a curve shape. And so this is what that graph is going to look like. Okay, we'll talk a little bit more again in the next video about when you get a curve like this, when you get this sort of a U shape, but for now I'm just concerned with you graphing it on your calculator and then using your table to get that same shape. Is this graph increasing or decreasing? Well, for this particular shape, we're going to say it's doing both. As you move from left to right, at first your y values are going down, okay, so they're decreasing. But then you hit this point right here. This would be the bottom of our U, which we would also call the minimum point. So this graph, I'm going to skip down to the next question, does have a minimum. And then after you go past that point and you move from left to right, you'll notice the y values start going back up. And so this graph, not only is it decreasing, but it's also increasing. So it starts out decreasing, and then it starts increasing. Okay, and finally the question's asking, is the graph a curve or a line? Well, this one would obviously be a curve. Okay, looking at number 4 now, we have the function f of x equals x to the third power, or x cubed minus 4. Okay, so my y values, again, -2, -1, 0, 1, and 2. I'm going to plug each of these in, and then I'm going to take that number to the third power. And then after that, I'll subtract 4. Okay, so let's go to our graphing calculator. We'll go ahead and clear this graph here off. Hit delete 3 times. Okay, so this time hit tab. I'm going to graph x, and then to do anything besides a 2 exponent, you actually have to hit the caret button, which is directly next to the x squared button right here. That's going to put in an exponent box, and then we're going to type in this case, a 3. And then after you type in that exponent, you need to arrow right so you can get back out of the exponent box. So we're going to do x cubed subtract 4 for this graph. Hit enter, and we get sort of this weird squiggly S shape. Okay, so this is what our graph should look like when we plug in each of our points. So now we'll go back and we'll see if we can get this shape. Anytime you're cubing a number, that means you're taking it times itself 3 times. So a negative times itself 3 times is going to give you a negative again. Negative 2 times negative 2 is 4, times negative 2 again is negative 8. So we'll do negative 8 minus 4, which is negative 12. And then we get negative 1 minus 4, which is negative 5. 0 cubed is 0, so you get 0 minus 4, which is negative 4. 1 minus 4 is negative 3. And then 2 cubed is positive 8. So 8 minus 4, we get positive 4. So my points are going to be negative 2, negative 12, which negative 12 is going to be off the coordinate plane a little bit, about right down here. Then I get negative 1, negative 5. 0, negative 4, 1, negative 3, and then 2, positive 4. So we do get that same sort of shape we saw on our graphing calculator. It's going to be, again, this weird little S shape. The important part about that is I want you to see that this is a curve. Okay, it's not a straight line, but you do get sort of this curved shape. And unless you're really artistic, it's kind of hard to draw. That doesn't have to be perfect, just has to be connected, and again, a curve shape here. The questions we want to answer: is the graph increasing or decreasing? As we move left to right, this is increasing. Okay, the y values are getting larger, so we'll say this is an increasing graph. Unlike the U shape, there is no minimum point on this. Okay, it keeps going forever downwards this way, forever upwards this way. So we say none, no minimum and no maximum. And finally, this would be a curve, not a line. Okay, number 4, we have f of x equals the absolute value of x minus 1. So we're going to be bringing back absolute values to some of our graphs here in this unit. You guys remember solving absolute value equations and inequalities in the last 2 units. Had a lot of fun doing that, you see. So now go back to your calculator screen. I've deleted my graph off here. Again, hit delete 3 times, and you can do that to yours. I'm going to hit tab, and then we're going to go ahead and bring up absolute value bars. If you remember from when we did absolute value equations, this button next to 9 right here, you can hit that button. That'll bring up this screen right here, and your absolute value bars are going to be this leftmost box in the middle row. So if you click this button right here, that's going to throw in some absolute value bars, and now you just want to type in x minus 1 inside those bars. And then you hit enter, and you're going to get this sort of a V shape for your graph. Okay, so when we do our table, we want our graph to come out to be a V sort of shape. So now let's go ahead and let's graph this. Okay, so each of our x values here we're going to plug in, and then we're going to subtract 1, and then once we get that number, we're going to take the absolute value of it. Okay, so the first number I'm going to plug in is a negative 2. So we'll do negative 2 minus 1, which is negative 3. The absolute value of negative 3 is 3. Then I'll plug in negative 1. So we get negative 2. The absolute value of negative 2 is positive 2. Then we plug in a 0. 0 minus 1 is negative 1. The absolute value gives us positive 1. Then we plug in 1. 1 minus 1 is 0. Absolute value of 0 is 0. And then finally we plug in a 2. 2 minus 1 is 1, and the absolute value of 1 is 1. So now we're going to plot these 5 points: negative 2, 3, negative 1, 2, 0, 1, 1, 0, and then finally 2, 1. And so you see, without our calculator, we might have thought this was going to be a line, but this last point, 2, 1, we expected a V, and now we can see we're getting this V sort of a shape because now it's going back up this way. So now you're going to connect those points, again, using a straight edge, because for a V, you're going to have some lines here. So we're going to try to make this as straight as possible. We're going to go down until this point 1, 0, and then we're going to start going back up this way. And we should get a graph that matches pretty closely what we got on our calculator. Okay, so now we're going to answer these questions about the graph. Number 1, is the graph increasing or decreasing? Well, just like that U we got for number 2, it's actually doing both. Okay, at first the y values are decreasing, but then we hit this point right here, which would be the smallest point on our graph, the lowest point, so that would be a minimum. And then the y values start going back up again, so then after it decreases, it starts increasing again. So this would be decreasing, then increasing, has a minimum, and this graph, even though it isn't an actual line, it is made up of line segments. So I'm going to call this a line anyway, just because it's made up of 2 line segments. By the way, I know we've had 2 minimums for our graphs. If you ever had a graph that looks like this, sort of an upside down V, this would be an example of a graph that increases then decreases and has a highest point or a maximum. So graphs that are sort of upside down, V's and U's, those would have maximums as opposed to minimums. Okay, a couple more examples. Number 5 here, we have f of x equals 2 to the x power. Okay, so for this one, when I plug in my x values, I'm going to be plugging them in for the exponent, not for the big number. So every time we're going to be taking 2 to a different power, and that power is going to be each of these numbers here. Okay, so we're going to have 2 to the negative 2 power, 2 to the negative 1, 2 to the 0, 2 to the first, and 2 to the second. Again, before I fill out my table, I'm going to go ahead and graph this so I can get the shape. So we'll delete our last graph, hit tab, f of x equals 2, then I'm going to use my exponent key, or my caret symbol right here, and I'm just going to type in an x for my exponent. And then I'll hit enter, and I get this sort of a curvy J shape. Okay, you see it's flat over here on this end, and it becomes almost sort of a straight line as you go further and further this way. It doesn't actually become a line, but it looks pretty close to one. So we're going to see if we can get that shape now for our graph. I'm going to start here at the bottom because we know what 2 to the second power is. 2 to the second means 2 times 2, which is 4. Then 2 to the first means 2 itself, okay, so 2. But then a 0 exponent and a negative exponent you probably haven't seen before this. We are going to do a unit over exponents, and so you'll see this a lot more in Unit 7, okay? And so we'll talk about why you get some of the answers you do when we start doing exponent properties in Unit 7. But for today, all I want you to do is type this into your calculator and accept what it says to be true. Okay. Again, we'll talk about the details of why you get the answers you do in Unit 7, but for today and for the rest of this unit, you're just going to let your calculator calculate these values for you. So starting right here, 2 to the 0 power, I'm going to go to my scratch pad, so I'm going to hit this button right here, and I'm just going to tell my calculator take 2 to a power, so use my exponent key of 0. And when I hit enter, it tells me it's 1. Which sounds like an odd answer, but that is correct. 2 to the 0 does give you 1. Next, I'm going to type in 2 to the negative 1 power. So 2 exponent key negative 1. I get an answer of 1/2. That is also correct. And then finally 2 to the negative 2 power. 2 exponent negative 2, you get an answer of 1/4. Okay, so 1/4. If you can't wait until Unit 7 to figure out why that is, feel free to research this on the internet if you'd like to, but just trust me, those are the correct answers. So now I'm going to plot each of these points, starting with negative 2, 1/4. That's going to be left 2 and up about 1/4 of the way right here. Then we have negative 1, 1/2, which would be about right here. 0, 1, right there. 1, 2, and 2, 4. And we do get, again, this sort of a curvy J shape. So it's going to do this, and then come down here and become almost a flat line this way. Okay, so to answer these questions about our graphs, is the graph increasing or decreasing? This would be an increasing graph, because as we move left to right, our y values are going up. There is no high or low point on this, so we say there's no minimum or maximum, and of course this is a curve. Okay, and then finally for example 6, we have f of x equals the square root of x plus 1. So again, choosing the same x values we've been using every single example. I'm going to be plugging in my x value. I'm going to be taking it plus 1, and then I'm going to be taking the square root of whatever number I get from there. And again, before I do that, let me go to my graphing calculator and see what shape I'm supposed to get. So go back to your graph screen, delete your last graph, and we'll type in, to do a square root button, you have to hit Control, and then the square root key is actually your x squared key after you hit Control. You see that blue square root sign above it? So if we hit Control and then our x squared key, that's going to put in a square root symbol. And now we'll type in x plus 1. And we get this sort of a curve shape, but notice it doesn't go anywhere past this point -1, 0. Okay, it actually has a starting point, and we're going to see why in just a second, that this graph right here has a starting point, okay, at -1, 0. So I'm actually going to start down here at the bottom, filling out this table. So when I plug in a positive 2, I get 2 plus 1 under my square root sign, which gives me the square root of 3. To figure out what the square root of 3 is, you're going to need to use a calculator to approximate that. So if I go to my scratch pad and I type in the square root, second x squared, of 3, I get approximately 1.7. So we're just going to say that's about 1.7. Same thing when you plug in a 1. 1 plus 1 is 2. The square root of 2, that would be irrational, so we're going to have to approximate that again. Square root of 2, you get about 1.4. Okay, which is right here. Then we plug in a 0. This one's nice. 0 plus 1 is 1. The square root of 1 is also 1. Then I plug in a -1. -1 plus 1 is 0. The square root of 0 is 0. And so what I'm going to do right now is I'm just going to plot these 4 points here, and then I'm going to go back to this -2 here at the end. So I've got -1, 0, which is right here. 0, 1, right here. 1, 1.4, which is right here, and then 2, 1.7 about right here. And so go back to your graphing calculator, go to your graph screen, and notice that this graph starts at the point -1, 0. And so that's we have -1, 0 right here. So if we follow our graphing calculator, this is what the graph should look like. Well, I've still got the x value of -2 that I need to plug into my equation here. I'm going to show you why this graph has a starting point at -1, 0. When I try to plug in -2 to my function, I get this. I get the square root of -1. The definition of a square root is that any number times itself is the definition of a square root is that you have to find the number that times itself would give you what's under the square root sign. Well, if we try to take a number times itself to get a -1, we're going to be thinking a long time about that number, because there is no such number. Every time you have a positive number times itself, you get a positive. Every time you have a negative number times itself, you get a positive as well. So you can't take a number times itself to get a negative number. Okay, so we would say that the square root of -1 and actually the square root of any number is undefined. So when you plug in a -2 for x, you get an undefined value for y, and so that means we can't plot that point. So that is why we have a starting point at -1, 0, because anything past this is going to be undefined, so we can't plot it on our coordinate plane. Okay, that's a concept we're going to be talking more about over the next couple of years. For right now, again, just trust me on that one. You can't have a point here past -1. So graphs of this type right here, the square root graphs, are going to have starting points. To answer the questions about this graph, really quick to wrap things up, is it increasing or decreasing? The y values are going up, so we call this an increasing graph. It does have a low point. Okay, this point right here would be the lowest point in the graph, so we would say there is a minimum. And of course this graph right here is a curved on a line. Okay, I realize this was a long video and there are probably a lot of questions you might have, so feel free to jot those down, rewatch anything you need to. We'll try to answer a lot of those questions in class the next time I see you. Until then, have a nice day. You're all wonderful people. Take care.